Good afternoon, everyone. Let me introduce myself. I am Badhan Sen. I am a research assistant at UCD School of Agriculture and Food Science. I thrill to announce that today we will talk about our groundbreaking project, HOLOS-IE, which is led by Dr. Ibrahim. And today, main topic is how we are bridging the gap for sustainable agriculture and carbon neutrality. But before starting, I will talk about in the perspective of software engineering, how we develop this solution, what difficulties we have faced, and what challenges are ahead in the future. Okay. So this is our diagram for HOLOS-IE, whole farm-based model. So let's go. So we want to talk about sustainable farming, climate change, and environmental pollution, and also inform policy and decision making. We have some groundbreaking items here as well, like we have GIS members and database that we have collected the data from Irish perspective. We have also the satellite data for climate changes. And we are developing a software solution, HOLOS-IE. So, and we also develop some of the algorithms that my teammates have already shown here. Like Meher is developing a agroforestry module for HOLOS-IE, and Anastasios is integrating bioeconomic into HOLOS-IE. So let's dive into our prototype. So this is our prototype icons. You can see, like, okay, this is the front page. So this is our first version, HOLOS-IE. And I also want to thank about like Agriculture and Agri-Food Canada for developing the HOLOS. We are developing on top of HOLOS, and we are integrating it for Irish environment. Let's so this is some of the few pages I have included. Like you can create a new form, or you can open an existing form that you have already have. You can just edit it from where you have gone through. So also you can import. So you have a farm that is already developed or already created. You can just import it from one computer to another computer. And you can create a name so that you can easily identify your farm location, something like that. And we have also a county. So let's talk about the Irish county. So we are separating the Irish map into 26 counties so that you can identify your farm location very easily. Like you will go to your county, then a visual Irish map will appear. Then you can see there will be a lots of polygons. Then you can select any of the polygons, and then the soil data will automatically come. So let's see. Okay. So I am selecting a point. So now you can see I'm getting the automatic soil data. And I also want to include something like if you have already a soil data on your specific farm, you can also include that data into our software. And we have also another things like climate data. So from the very beginning, we actually collected the data from NASA API. So in perspective of latitude and longitude, we are collecting the climate data. But don't worry. If you have your climate data, you can just include it into our software. Then it will work on your data, not the data from the NASA API. And now, and to go back a little bit. So here you can see I have some safe farms, like farm with 10% agroforestry, farm with 20% agroforestry. So as Mehezabin already talked about the agroforestry we are working on, this is the same model. So just I am clicking any of this model farm, then I can just edit it from where I am left. So now go back. Now I want to talk about all of the available components that are available in HOLOS-IE. So there are around 30 components currently available, and we have planned to increase the component numbers in futures. So you can see on top of that is the agroforestry component. So there are other components as well. There are 4 different types like site characteristics, land use and management, livestock, and another one is infrastructure. So from this component, you can pick any of the component and work for your farm. So now I want to create a farm with a grassland and dairy. So this is the details I am taking. These details will be taking into consideration into the input of our HOLOS-IE software. So let's go. So I have selected a grassland and a dairy cattle. So now I will input all of the information that I have shown previously. So I will take this input into our software. So by this way, I will take the input. Okay, the input is done. Then, so now I can show you the results. What will be the result? Let's see. Okay, now you can see we have a multi-year carbon modeling for the grassland. And now go. This is the fish estimated report. So like carbon modeling, estimation of production, manure management, economics that has been working towards, like Anastasios is working towards the economics. We have the emission pie chart. We have also the overall emission, component emission, also the agroforestry and the detail emission. So these are the result section we will be talking about. So you can see the result is coming. Then emission result. This is the overall emission. This is the component emission. This is the details emission. So now let's go back to our main page, like where we created the farm. We can edit it again and see the result in hand. Like we will change some of the inputs, then the result will change according to the input. And if we have the correct data, like farm specific data, this result will be very much accurate. So now I want to talk about a comparison. Like now I will add 10% agroforestry into our existing farm. So this is the agroforestry we are talking about. Like I am taking silvopastoral, oak tree, then hedgerow, sycamore, and I have given the information here, like the number of trees, the cutting year. So this all the information I am considering now. So let's see. So let's see. We have this 2 agroforestry system. So one is for silvopastoral and another is for hedgerow. So now I can take all the inputs that I'm talking about, and we have also the plantation area, tree spacing, management practices, and logging. So each of this section of the inputs, if I have the data, the farm specific data, then the result will be pretty much accurate. But unfortunately, we don't have enough data. So that's why we are iterating our model. When we find enough farm specific data, then we can evaluate our model with the actual result. So we want to go through as close as possible to the actual result. So now go. So this is the hedgerow inputs. And now let's see what is the result. So, and now we can see that the total carbon balance. So this is above ground biomass, below ground biomass, total biomass, soil organic carbon, nitrogen, and total carbon balance. So I'm getting all of the results. So now the net balance. So as I have already told that we have a farm with grassland and cattle. And for the grasses, I have this carbon. And for the livestock, I have this amount of carbon. And for the agroforestry, I have this amount of negative carbon. So I have some net balance gain, positive. So, so still, I am not getting close to carbon neutrality. So let's increase the percentage. I am talking about 10% now. I will increase it 20%. 20%. I will include 20% agroforestry into my farm. So how it will look like? So all of the inputs are here. So I am considering the trees number will be greater. So like previously I'm considering 150. Now I'm considering 300. Now I am here considering 490. So after all, I will take all the inputs. This will be the agroforestry 1. This will be the agroforestry 2 hedgerow. So then all of the inputs are taken. Now see the results. So now you can see a dramatical change in terms of carbon balance, total balance. Total balance. So now go to the net balance. So now it is negative. So now the carbon, we are getting some benefits, like we are planting trees and the carbon is like we are taking the carbons, we are reducing the carbon towards the carbon neutrality, because this is the negative section. So the environment is now free with carbon. So because when we first came here, we have seen that we have a positive net balance. So we need to reduce it as close to zero. If we use 20% agroforestry, we see a dramatical change in net balance. So in here, you can see that in this software, you can just take the inputs and you will estimate the result, how your future will look like, because it will not happen over the year. You have to plan for the 10 years, 20 years, because if you see the result in hand, you have to wait for a long time. And we also like considering some policymakers, farmers can get benefited by the software, because he can know what he can achieve in future. So now you're seeing this, okay, if I plant 20% agroforestry into my farm, then after 10 years, I will get some benefits from the government, from the stakeholders by showing these results. So this is our main perspective. Like we want to help the farmers, the policymakers and stakeholders. Those are really concerned about the environment, want to improve our lives through carbon neutrality. And also there will be like, there will be a climate change everywhere. Like the global warming is a top of the notch problem nowadays. So we have to find a way to challenge this. So I think this is the most important aspect in our today's session. So now this is the comparison between two systems. Okay. Now, okay, the future plan. So we are working towards this project a very long time, and we have a really visionary goal. So like we want to include artificial intelligence into our system. Like you all know, today's world is really evolving. So like in every system, AI is integrated. So we have a plan to integrate AI into our system, like 10% agroforestry, 20% agroforestry. So like we want to take all the inputs into the system, then the system will suggest, okay, if you plant 20% agroforestry, then your farm will be carbon neutral. based on your farm specific data. And we have also planned for the like we are developing HOLOS-IE, but in future we want to develop it for HOLOS-EU. It will be across Europe. We can create, we can vision all of the world that we are developing it. You can use it, you can benefit it from this. And also I want to mention one thing, like currently we are developing this software for Windows application only. So like you can run it only for Windows. But in future, we are thinking about moving to web-based platform. And I know there will be some data breach, data security as well. And we are also consideration of all of this term, like we will be secure enough that every user data will be secured into our system. So no, there will be no data leak. And I know it is really impossible to tell that there will be no data leak. But we want to create a system that will be reliable for every user across the all Europe. So now I want to acknowledge all of our collaborators, funding members, and institutions. So thank you so much for joining this conference and session. Thank you. And please visit this website. Then you can find some insight about our project. Thank you so much.